Welcome, geometry students, to class today on this wonderful Monday, 11/11/13. Hope you guys had a good weekend and hope you're ready to learn some math today. Your tests are graded and I will pass those out. Jay, so do not feel any pressure to rush into the test, but as soon as you have taken that test, I will pass the tests out to the rest of the students. But do not take it until you're ready for it. Okay, a bunch of announcements here. Okay, is everybody ready? Here we go. Number one, there will be a quiz on Wednesday. I will give you details about that tomorrow. Quiz on Wednesday. One person turned in the homework early. Now, Martin, I think it was you, but I could be wrong. But Friday's homework, page 286, 8 through 16, 21 through 26, is due today. And again, only one person. Jace, I think you were absent on Friday again, I'm pretty sure. And that's why you see why I have this assignment right here down by your name. We're going to talk about that in just a second. So please don't in any way be embarrassed. This is just my only way of communicating with you on the class here. But anyways, let's see. So please turn in Friday's homework right now. Make sure your name is on it and turn it in. You were given this assignment on Friday, and it's due today, except for Martin. He turned it in early. Jay said, this is Friday's assignment right here. I don't expect you to have it done, okay? So that's fine. I'm just showing you 3 assignments that you really need to get turned in as soon as possible. And of course, when I say as soon as possible, I'm saying when you're ready to, of course, make sure you understand the material. But here are 3 assignments you're missing, so you can go back and look at this later. Jace, I'm really trying to help you here. Skip the quiz this Wednesday. Now, if you're like, if Wednesday rolls around, Jace, and you're like, man, I know that material, I don't want to skip that quiz. That's a grade, an easy 100. Then take it. You know, by all means, take it. But you are welcome to skip the quiz this Wednesday and not make it up. Okay, because I want to get you caught up, and it's very important to me that we do that. Okay, so if I can help you by saying, look, just skip the quiz, don't take it, and let's focus on this makeup test that you got to get made up. Okay, that's up to you. I'll let you make that decision, but if you skip it, you don't have to make it up unless you want to. Now, you do understand you're missing a quiz, but I told you that we'll take the test grade and count it for a quiz grade, and I will definitely work with that grade maybe and round it up for your quiz if you don't do well on your test. Okay, now I'm trying to be so helpful here to you. The fill in the blanks, Jasa, Azu, Jake, and Haley, you didn't take the test yet, but Martin, the fill in the blanks hurt you guys quite a bit. So Jasa, please study the fill in the blanks. Email me, and remember guys, email me at my other email address now, earhartmichael@gmail.com. It's very important you do that. I do not check the other email hardly at all. So if you don't listen to me, it's going to hurt you, not me, okay? Because I'm not going to get your emails till like late at night right before I go to bed. I check it. So this email here, I check it 100 times a day. All right. So Jason, let's just say let's get one of the parts of the test taken by Tuesday or Wednesday, and the other part by Wednesday or Thursday. And I think it's fair enough. And contact me if I can help you over the phone or somehow meet with you. I'm not sure how we would do it, but I'm willing to do that. If we can work that into your schedule and mine, I will do that. Now, Haley, when you see this down here, don't freak out. Remember, there was one assignment where you could not get the video thing to work, and I had to give you some suggestions on that. So I just didn't count this assignment against you. It was the very first assignment I gave you. You didn't get it done. I didn't count against you, so don't worry about it, okay? So far in your grade book for you, you've had one homework assignment. You did it, you turned it in. It was Friday, and you turned it in early. Actually, you and Martin did, so that's my fault up here. When I said turn in Friday's homework, you and Martin turned that in early, and I apologize for not mentioning that earlier up here. So you're good. Don't worry about the one that you couldn't get to work. I just didn't count against you, and you'll get used to the system as we go. Students, the key to this class working is you studying, working hard, never missing a video. And by the way, when you're absent, like Jason's been absent, guys, when you're absent, call me, email me. I will tell you what video to watch. Now, I know if you watch it at home, it'll probably make you sicker. Okay, I understand it's not the highlight of your day, but you can stay up on this class if you watch the videos at home. Okay, and the key is working hard, and the key is contacting me. me, calling me, emailing me, and working together on this, okay? That's very, very, very important. Okay, grab your notebooks, grab your pens, pencils, calculators, books, and let's go ahead and jump into today's notes. So here we go. We just finished a chapter on triangles, okay? Now, please don't forget what we learned. We just finished a chapter on triangles. Please don't forget what we learned. We learned what congruent triangles are. All three angles and all three sides of one triangle must be congruent to all three angles and all three sides of another triangle. We learned 5 ways to show that triangle, that should be triangles, shouldn't it? That triangles are congruent. And those 5 ways are side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg. Please don't forget that. We learned corresponding parts of congruent triangles are congruent. In other words, if I tell you this triangle here is congruent to this triangle here, you know that the angles are going to be congruent and that the sides are going to be congruent. I'm not going to draw all that up, but you get the idea, okay? And so we learned that. And then we learned the angle bisector theorem, and here's what I taught you. I said if you have an angle with a line coming down the middle of it, and this angle here is congruent to this angle here, and we have a right angle here and a right angle here, then this segment right here is congruent to this segment here. This segment right here is congruent to this segment here. And then we learned the perpendicular bisector theorem, okay? And what I taught you there was this. I said if you have a line right here intersected by another line like this, so if you have 2 lines intersecting in such a way that this segment here is congruent to this segment here, and we have a right angle here, so these 2 lines are perpendicular, then this segment right here will always be congruent to this segment here. All right, and that's pretty much what we learned in the last chapter in somewhat of a nutshell. Okay, now we're going to go ahead and copy this down while I'm talking. We're going to start studying polygons today. Now this chapter, let me talk to you about chapter 6 while you're writing down this heading. Okay, chapter 6, we're going to study quadrilaterals in a deeper manner. We're going to look at parallelograms and characteristics of parallelograms. We're going to look at how to decide different ways to prove that a quadrilateral is a parallelogram. We're going to look at rhombi, which is plural for rhombus. Some books, this book says rhombuses. Most books say rhombi. Either way, we're going to look at rhombuses, triangles, rectangles, squares, all kinds of different polygons, trapezoids, parallelograms. And so those are all quadrilaterals. We're going to start the chapter off, though, lesson 6.1. The date today is the 11th, if you want to make note of that. We're going to start off looking at polygons today. It's a typical opening lesson in a chapter. I think you'll find it pretty easy. And let's go ahead and get started. Let's start off first of all with the definition of a polygon. A polygon is, please write this in your notes, you will be responsible for this coming up on quizzes and tests. A polygon is a plane figure that is formed by 3 or more segments called sides. Each side intersects exactly 2 other sides at its endpoints. Now that's real important that you understand what it's saying there, because let me give you an example of a polygon and show you what is not a polygon, okay? That would be a polygon. Looks a little weird, but that would be a polygon. We have all of these segments, and notice where they connect. This is very important. They connect at the endpoints. In other words, nowhere do you have one of these segments or one of these sides intersecting in the middle somewhere, like this. Watch this. That would not be a polygon at all, because notice this segment right here and this segment right here are intersecting right here in the middle. That would not be a polygon, okay? Polygons only intersect at their endpoints of all the sides, okay? And here's something else that would not be a polygon, by the way. If you have rounded sides like this, and then this, like a key on a basketball court, something like this, that would not be a polygon, okay? Because it's not a segment, we have a curved side here. And the definition says a plane figure formed by 3 or more segments, and a curved side like that is not a segment. Each side intersects exactly 2 other sides at each of its endpoints, okay? And so that's what a polygon is. You need to know that, okay? Now we're going to work on some problems here in a second, and you can just kind of follow along, okay? Now each endpoint of a polygon is what we call a vertex. So write this in your notes. You need to know this. A vertex is each endpoint of a polygon. So you don't need to write this down here. Just watch. Here's a triangle. Obviously, this, let me get my pen back up here. This, and this, each of those would be a vertex, or the plural of that is vertices. You don't need to know that. I'm just telling you so you know how to speak properly, okay? So this triangle has 3, don't say vertexes, it has 3 vertices, okay? This is a vertex, this is a vertex, this is a vertex. Now let's get a really crazy looking polygon up here. One that goes off the screen a little bit there. There we go. Pull it back on here. And, okay, now this would be a vertex here. This would be a vertex here, this would be a vertex, this would be, and this would be, okay? So those are vertices. It's each endpoint of a polygon. So do you understand what a vertex is? I hope that you do, okay? So a vertex is each endpoint of a polygon. Now, continuing on, what is a diagonal? You need to know this. I'm going too fast. Pause the video and back it up. A diagonal is a segment that joins, listen carefully, 2 non-consecutive vertices of a polygon. Non-consecutive means this. If you want some help there, it means they can't be side by side. Maybe that'll help you a little bit understand that. Non-consecutive means a segment that joins 2 vertices, but these 2 vertices can't be side by side, okay? 2 non-consecutive vertices of a polygon. A picture's worth a million words. Okay, let me go ahead and draw a rectangle up here for you. There we go. Now, if I said draw a diagonal, okay, no problem. Here's a diagonal. There we go. That's what it says. A segment that joins 2 non-consecutive vertices. Well, this is a vertex, and this is a vertex, and I just joined them with a line. That would be a diagonal. Here's another diagonal. There's another diagonal. You just joined 2 non-consecutive vertices. Well, Mr. Earhart, what do you mean by non-consecutive? Well, see this vertex here? See this vertex here? Aren't they side by side? Sure they are. So you cannot connect those 2 and call it a diagonal. You cannot do it. See this endpoint here, this vertex, and this vertex here? You could not connect those 2 vertices and call that line a diagonal. It has to be 2 endpoints or 2 vertices that are not side by side. So this endpoint here, this vertex here, and this vertex here, they're not side by side at all. So you can draw a diagonal. A rectangle has how many diagonals? 2. Let's get one more figure up here. Let's draw something like maybe a heptagon or a hexagon. There we go. All right. Now, you could not draw a diagonal from here to here because those are consecutive vertices, but you could definitely draw a diagonal from here to here. You could draw one from here to here. You could come here and draw one over to here. You could draw one over to here. Let's see, you could draw one over here. Okay, so there's a lot of diagonals that you can draw in different polygons, but the key, what you need to understand, is that you cannot draw a diagonal and connect 2 consecutive or 2 side-by-side vertices. Okay, so let's very quickly review. Do you understand what a polygon is? It is a figure formed by 3 or more segments called sides. Each side intersects exactly 2 other sides, only at its endpoints. And then what is a vertex? Well, it's all these corners. It's where all of the sides intersect or connect. That's where a vertex is. Then, of course, a diagonal is a segment that joins two non-consecutive vertices or two vertices that are not side by side within a polygon. Okay? All right, let's continue on. I hope this helps. I'm probably putting you to sleep. Now, we're going to look at 4 problems here, and then here, and then here. I really don't think you need to take notes on this. Now, if you want to, please feel free to. Don't feel dumb because you want to take notes. I think you can just kind of sit back and look and understand what I'm saying. I want to go through very quickly, and you're going to do this in your homework tonight, and I'm going to say, yes, this is a polygon, or no, it's not. So let's take a look at this one. When I look at this shape right here, I say, yes, it's a polygon. First of all, look at all the sides. They're all segments. Number 2, they all intersect at the end points of each segment. They're not intersecting in the middle anywhere. So that's a polygon. Now let's come over and take a look at B. Is this a polygon? Well, hopefully you call it out or quietly call it out to yourself, no. Because I have a curved side. And a curved side is not a segment. And a polygon has to be made up of all segments. This is a segment, this is a segment, and this is, but this is not. So no, this would not be a polygon. Now this here, really, you might say, Mr. Earhart, this doesn't break any of the rules. Just because it doesn't connect here doesn't mean it's not a polygon. Hold on, look at your definition, guys. Each side intersects, exactly how many other sides? 2. Each side must intersect 2 other sides. And where must they intersect at? At the endpoint. So let's go back and look at this object right here. Look, this segment here intersects 2 other segments. This segment here, let me show you. This segment here intersects 2 other segments here and here. This bottom line here intersects 2 other segments here and here. But see this side right here, this one I'm highlighting, it intersects only one side. And that's no good, okay? Notice this side up here. It only intersects one other segment right here. It doesn't intersect another segment. Now, we could definitely fix this by simply going like this, and now I have a polygon, okay? But no, this is not a polygon the way it is. Now this is, I have no problem with this. Doesn't matter if it's indented right here. Every side is a segment, and every side intersects exactly 2 other sides, or 2 other segments, and it intersects at the endpoints. Okay, we'll go a little faster now, okay? All right, get a different color up here. Yep, this is definitely a polygon, no doubt about it. All segments connect at the endpoints. This is definitely not a polygon. It's curved, it's curved. And now you can see why I didn't really want you to take notes. I just want you to sit back and listen, because I think it's going to be common sense. This would be a polygon. If you don't think it is, then, you know, kind of ask yourself why. Why would it not be a polygon? You got a segment, 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 segment. They all intersect 2 other segments, and they all intersect at their endpoints like they're supposed to. They intersect exactly 2 sides. This is not, no. And I can show you why. I can show you why right now. Mr. Earhart, it's all segments. So what's wrong with this? Well, I'm going to show you. Remember, each side has to intersect exactly 2 other sides at its endpoint. So actually this thing fails twice. First of all, notice this segment right here I'm highlighting has 3 intersection places. 3. Count them. 1, 2, 3. So that's wrong right there. Secondly, when it does intersect another line, it has to intersect at its endpoints here and here. It cannot intersect in the middle like that. So no, that is not a polygon. All right, let's take a look at this one. There's no way this is a polygon. No, it didn't connect. We could fix it real quick if we wanted to, but no, that is not a polygon. This is definitely a polygon. No problem with this at all. I mean, my goodness. All the sides, they all connect at their endpoints. Each side is intersecting 2 other sides. Perfect. Yes, definitely. This is a trapezoid, by the way. Well, as long as this side here is parallel to this side here, then we have a trapezoid. Yes, that's a polygon. Yes, definitely. No, this is not. You should know why, right? We have a rounded side right here. And a polygon has to have all segments. Let me grab a quick drink of water here. Okay, students, pretty simple? I think so. Pretty easy? I think so. But let's make sure we understand it and let's go over it, okay? So sorry, excuse me. So far we've learned the definition of polygon, vertex, and diagonals, okay? Now let's continue on. You don't need to memorize these, but be familiar with them. You don't have to turn to page 304 unless you want to. You're welcome to. So feel free to if you want to. You know by now this is a triangle. Any four-sided shape is called a quadrilateral. Any five-sided shape is called a pentagon. Any six-sided polygon is called a hexagon. Any seven-sided polygon is called a heptagon. And any eight-sided polygon is called an octagon, okay? I think an octopus has 8 legs. You can remember the octagon, 8 sides. Hex, and I'm not, guys, this might be a little weird. This is how I remember it. I mean, usually when you think of a hex, of course, we're a Christian school. We don't believe in the witches and all that. I'm just simply saying that when you think of a hex, you usually think of a witch. And, of course, usually the number, 666 or 6. And that's kind of an easy way to remember this one. So that's how I remember that, hex. And usually when you think of hex, usually you think of the number 6 that would go with that. So a hexagon is 6. Pentagon, think of the building in, is it Washington, D.C., the Pentagon, or is that in Virginia, right next to Washington, D.C.? Anyways, the Pentagon, the building, the Pentagon has 5 sides. So a pentagon is any polygon with 5 sides. And of course, quad means 4 and tri means 3. So I'm not going to quiz you on these yet. I don't believe. I'll let you know if I do. But it's definitely your job to be familiar with these, okay? These are all polygons, okay? 3, 4, 5, 6, 7, and 8-sided polygons. Let's continue on. Now, of course, I'm joking with you, but how could we have a geometry class without a theorem, okay? And you're probably thinking, well, I wish we did, but unfortunately, we do have a theorem we have to learn today, so please write this down as I talk to you about it. Theorem 6.1 is called the quadrilateral interior angle theorem, and it states this: the sum of the measures of the interior angles of a four-sided polygon quadrilateral is always going to be 360 degrees. Let's go over that again. The sum of the measures of the interior angles of a quadrilateral, a four-sided polygon, is always going to be 360 degrees. Now, we learned earlier that if you have a triangle and you add up all 3 angles, angle 1 plus angle 2 plus angle 3, the 3 interior angles of a triangle always add up to what? 180, correct? Sure. And so now we learn that the sum of the measures of the interior angles of a quadrilateral is always going to be 360. Now please don't write this down. I'm going to try to prove it to you very quickly. Don't try to write this down, please. Do you realize any quadrilateral that you draw can be divided up into 2 triangles with just by connecting a diagonal? So if I draw a diagonal like this, not the best, you can tell it's a little off, but you get the point. If I draw a diagonal like this, notice I have a triangle right here, this top triangle right here. Okay, and then I have a triangle here like that. Okay, and so what that means is, and I'm not going to go into a proof right now and get into all of this, but it's really easy to prove. You know the sum of all these angles in the triangle is 180, and you know the sum of all the triangles in this, the sum of the angles in this triangle is 180. So add them together and you get 360, and that's the reason we can quickly prove that a four-sided figure, if you add up all 4 angles on the inside, it is going to equal 360 degrees. Okay, let's go ahead and move on. Let's work some problems out together. Okay, I would like you to copy this in your notes, so would you please do that? Go ahead and quickly copy this quadrilateral, and notice I give you 3 angles: 1, 2, 3, and I want you to find this missing angle right here. Well, really it shouldn't be too hard. We notice right away we have a quadrilateral. How do I know that? 4 sides: 1, 2, 3, 4. I have 4 sides, and anytime you have a four-sided polygon, all the angles have to add up to 360. So far I have 110, 160. Add those up and you get 270. So if these 3 angles add together give me 270, then obviously this angle here has to be 90. Let's quickly add 90 to this, and you will see that you'll get 360. You can always check your answer by adding all 4 angles up and making sure they equal 360. Now that's pretty easy. Okay, all right, let's try one more. We don't do bonus points anymore. Oh, and by the way, if you're caught up on all your homework, and I don't mean if you've been absent like Jason has been. If Jason were to take the quiz this Wednesday, I have no problem with her having the 5 bonus points. I'm talking about people that aren't doing their homework. Haley, what I do is I give you 5 bonus points on your quizzes if you're all caught up on your homework like you're supposed to be. Okay, and so. So we're not going to do any bonus points on this, but I would like you to go ahead and copy this in your notes if you would, please. If I'm going too fast, just pause the video and rewind it and do it again, okay? But I'm going to keep moving on here. Go ahead and copy this in your notes, and I want you to find this missing angle right here, okay? I'm going to do it real quick off to this. Actually, I'm going to just pause for a second and give you a minute to work on this. See if you can get a head start on this problem and find that missing angle. I'll just kind of wait here for a second. I'm going to start working on it slowly. And of course, you've got calculators, so feel free to use your calculators. So the missing angle right here needs to be 65 degrees. If you add up 55 plus 80 plus 160 plus 65, you will get 360 degrees. Okay? All right, moving on. I think this is our last problem and we're ready for homework. Yep. So see if you can take a look at this, copy it in your notes quickly, and let's work on this. I want you to tell me the measure of angle W, and I want you to tell me the measure of angle T. Now, obviously, we cannot find the measure of angle W or T until we solve for X first, right? Common sense, we have to solve for X. So, here's what I'm going to do. I'm going to take all 4 angles and add them up. So, 90 plus 140 plus X plus 6 plus 3X. All of that equals 360 degrees, right? That's what I've taught you. When you add up all 4 angles inside of a quadrilateral, their sum is going to be 140. Well, we should know how to solve this from Algebra 1. First of all, look at your like terms. 90, 140, and 6 are all like terms. Let's add those together, and you'll get 236. All right? Now, here's another set of like terms. X and 3x. They're like terms. There's a 1 in front of this x. So 1x, even though you can't see it, 1x plus 3x would be 4x. And then bring down your 360. All right? And now we're solving for x, so we want to get rid of this 236, and we want to get rid of this 4. There are 2 numbers we want to get rid of. The first one we're going to get rid of is the 236. Notice right now it's a positive number. I'm going to bring it to the other side. When I bring it to the other side, it becomes a negative 236. And of course, it's now gone. So I'm left with 4x over here equals, and now let's see, it would be 40, 120, 124. I did it in my head. I hope that's right. 124. Okay? And now we want to get rid of the 4. So we have 4x equals 124. We're going to divide this side by 4. And we're going to divide this side by 4. Your 4's cancel. And x equals 31. That's not your answer. I didn't ask for x, okay? I asked for the measure of angle W and the measure of angle T. So let's find the measure of angle W. Let's go down here to W. W is 3x. So where the x is, I'm going to substitute 31. Okay? So 3x means 3 times x. And x is 31. So 3 times 31 would be 93. Again, feel free to use your calculators all that you want to. Now, right here for angle T, where the x is, I'm going to substitute 31. Notice angle T is x plus 6, or in other words, 31 plus 6, which would be 37. So if I add up all these angles, 90 plus 140 plus 93 plus 37, I should get 360. 0, carrier 1, 40, 230, 260, carrier 2, 3, 360 degrees, okay? So that's pretty much what the homework's going to be like tonight. They're going to ask you, to state whether or not you have polygons or not like this, and they're going to give you some problems to work on, okay? This homework is due by tomorrow. Please copy that down. Page 306, numbers 8 through 23 all. The homework you are to watch is Geometry 6-1 homework. Haley, you're new to the class still. The rest of you students, please listen. I make new videos every day, but I do not make new homework videos. So when you listen to this video, sorry about that, when you listen to this video, I think at the very beginning of the video I go over a quiz and I say, okay, tomorrow's a quiz. Just ignore all that. That's from last year. That's when I had Megan and Ashley and Kate and Tara, okay? All that you want to do, believe me, the assignment's just like this. It's just like that. So all that you want to do is go to this video and fast forward it until it gets to the problems right here where I'm working the problems out. Okay, but don't listen to anything in which I talk about quizzes or tests or makeup work or anything like that. Just ignore it. The only thing you're doing on this video right here is you're listening how to work these problems in case you get stuck. Call me or email me if you have any questions. I hope you guys have a great rest of the day, and we will talk to you tomorrow.